Okay, welcome everybody. My name is Jeremy Schneider.
Hi, I'm Jeff Davis.
Jeff and I are going to be talking about collation today. The way we're going to do this is that I'm going to go first, and then Jeff's going to go second. And this is going to be a little fun. So what I'm going to do is, for starting out, there's a lot of people here, and I'm going to try to catch everybody up. And what I'm going to do is speed run through about 6 years of history of Postgres and collation very quickly and at a very high level. And then what we're going to do after that is I'm going to hand it over to Jeff. We're going to kind of slam on the brakes, and he's going to go a little bit deeper and a little bit slower on a few specific topics about where we are now and where Postgres is going next, and some ongoing discussions and things like that. So with that said, let's get started. First off, just very quickly, I'm just going to give you some backstory. So there's just two things you need to know as backstory. First of all, Postgres does not have its own collation code built in, which is a little bit unconventional as far as relational databases go. It calls external libraries, such as the str call from the C standard. And part two of the backstory is that about 6 years ago, a whole bunch of people started noticing some not good things. And if you work with databases, these are not things that you want to see, right? So apparent data loss, constraints not being enforced correctly, crashes, in one case, crashes even during wall replay, which meant that a database couldn't even come back up because crash recovery couldn't finish. So this got a whole bunch of people's attention, and kind of long story short, at the root of a bunch of these things ended up being changes in sort orders, which is kind of an interesting thing. So that was 6 years ago. There's been a whole bunch of things going on. And like I said, I'm going to fly really fast over the last about 6 years. And I thought that the best way that I could do that would be just to walk you through 23 things that I got completely and utterly wrong about putting words in order. All right. Here's the thing. You might think putting words in order is a pretty easy thing. And I kind of thought this at the beginning, right? You just, I don't know. I speak English, it's pretty straightforward. There's like an alphabet, you just kind of start at the beginning, like doing mem compares. It turns out, if you've been around language, it turns out it's a little more complicated than that. In fact, there's a whole bunch of really interesting things that we as humans, if you think back to like your middle school grammar classes and all the rules that your teacher was trying to get you to learn, right? There's all kinds of weird rules that we come up with when it comes to language. Contractions, expansions, I kind of mentioned. The Unicode standard, and the Unicode standard kind of gets into a bunch of this. But it turns out it's a lot more complicated than you might think. So there's that. It's not quite as simple. The second thing I'm going to say is that I initially thought that the way computers and the way that people put words in order isn't something that would change. Right? So if there's a change in the sort order, surely it was a mistake by the maintainers of that library that you're using, right? Of course. Unfortunately, that turns out not to be correct either, because correct ordering can change. And I've thrown 3 examples up here on the screen from French and Tibetan and Swedish, and there's kind of a variety of reasons. The Tibetan one is kind of interesting. If you look, that actually was driven by the Buddhist Digital Resource Center, so they're working with historical texts and kind of correcting things. It does turn out that a lot of changes end up being maintenance types of things, but there are legitimate reasons, and it turns out that the way that we put words in order is a little bit more like time zones than it is like mathematics, right? Like the way you add numbers isn't going to change, but time zones occasionally do. And also, I like podcasts, so I wanted to throw this up here. This was a new podcast that just recently started, and the inaugural episode just a few months ago was an interview with Peter Eisenstraut. And this was just kind of a fun little thing that I liked, that, initially what we were doing with computers was we were trying to like get all the rules in the computer so that we could put words in order the same way that we do as people, right? And it's funny because what we're actually starting to see now is a circular relationship, where now one of the things that we observe is that like the way that we put words in order as people is actually starting to be influenced by computers. Because so much data processing happens on computers and everybody's carrying phones around in their pockets and things like that. So right, yeah, you might be forgiven for thinking that it doesn't change, but it does. But surely changing the sort order wouldn't happen very often, right? It'd be very rare. Now, there's a grain of truth in this, and the change that got everybody's attention back in 2018 was like this massive, large change, and that is rare. It's not often that you'll get like this big change. And if you're not familiar with this, you should be. I think a lot of people in here probably are, but just for the few of you that haven't heard about it, go to the Postgres wiki and check out that page. It is a scary massive, large change that even words that are just ASCII, nothing but ASCII characters, can change the way that they order. And this can lead to some of those scary things that I mentioned on the very first slide, like corrupt indexes and things like that, when that kind of changes underneath you. But something that I wanted to know, and a few other people were interested in, is like, okay, so there was this big change, but how often might we see kind of smaller changes? And so we came up with something that we have, actually, I think Joe kind of came up with the name, the Collation torture test, and I love it, so I'm running with it. And what we did here is we took 10 years of historical versions of both Ubuntu and Red Hat Enterprise Linux, every single assigned code point in Unicode, and we looked at 91 different string patterns and put all of that together, and you wind up with a list of about 26 million strings. And this isn't necessarily comprehensive or perfect, but it ends up being pretty good. We can then take that list and sort it on one system, sort it on another system, and compare and kind of see if you're seeing changes. And this ended up working out really well to tease out a bunch of changes as we looked at the last 10 years of Ubuntu and Red Hat releases. And the thing that we found was that every single Red Hat Enterprise Linux major release and every single Ubuntu LTS has sort order changes in the last 10 years. Every single one, except for Ubuntu 14.04. So the large changes may not be common, but unfortunately, it turns out like small changes are happening all the time and have been happening all the time all along. It's just not something that we really noticed. And just something I do want to mention, this whole like collation torture test thing is out on GitHub. You can pull this down. That's just a bit of, it's a bit of PL SQL code that you can run, and you can generate that list of 25 million strings for yourself. And then I grabbed a slide from, if you were at PGCon last year, you got to hear Joe talk about this, so I just put a picture of your slide right up there. He's got the, one of the things that's kind of cool that you can do with this now is you can use that SQL statement to sort the list, come up with the checksum, and you could actually build this right into a system test for yourself, or like into your own CI/CD type of thing, so that you could pick up if something inadvertently changed on the platforms that you're running on. So I was wrong. It's not uncommon. These actual little sorts are happening all the time, but surely it only happens on purpose, right? Right? It wouldn't accident. Unfortunately, it does sometimes even happen on accident. My favorite is this 300-line commit from 2014, which inadvertently changed sort order for 22,000 code points between glibc 219 and 221. And this was, if you look at it, by the way, it was just refactoring an internal cache to make things a little bit faster. And it didn't break anything. I have to make this clear. This was not a bug, because the words that were changing order were not words that, it was like if you had two characters next to each other from two different scripts. So there wasn't necessarily a defined, a linguistically defined correct or incorrect order. But massive amount of changes, kind of inadvertently. But fortunately, we know that the only thing that is corrupted here is indexes, luckily. So users are safe if you just rebuild your indexes, except for when it's other things, like this example from about a year ago on a blog where it was range list partitioning, and also like a number of other things. Like Joe had a great demo showing with foreign data wrappers that depended on the same ordering on the local and remote side, and a variety of couple of other things, and possibly even some unknowns. I'm not sure that we 100% have nailed everything down. But luckily, at least we know we can rebuild the objects and get out of pain. So it's inconvenient. But I'm happily, there's at least always a fix, right? Oh no. Unfortunately, there's this thing people like to do where they use hot standbys to scale out reads, right? Really, unfortunately, very common. So unfortunately, you can't really rebuild indexes on a hot standby, can you? No. So if you have spun up a hot standby, and your hot standby has a different library that has a different sort order, you're not rebuilding that. You're hoping that you didn't fail over first. And then secondly, you're shutting that thing down as quickly as you can, and you're going to build it again with the same sort order as your primary. All right. I realize you didn't come here to just have all your hopes and dreams dashed, but now you know what it's been like for the last 6 years for all of us. Fortunately, though, we were pretty sure that we could know that our database didn't have any Tibetan characters in it, surely. Or whatever that uncommon language is that had a sort order change. So I can safely update my sort library and just ignore the warnings about possible corruption, right? Well, just remember that right here in Vancouver, we probably have people from about every corner of the world, and just about 2 taps on my iPhone, And I can pull up a keyboard to write my name in any script that I want. I can also type emojis, any emoji that I can think of. And basically, anybody, if there's any kind of a data entry system wired up to your database, pretty much any character can wind up in there. So you kind of have to be careful. And unfortunately, I've seen a couple of situations where there were characters that nobody quite expected. And it turned out they were, in fact, in that database. But I'm sure the database would at least understand all the characters that are in it, right? Like if you saw a character in your database that said like unrecognized, invalid character, like that would set off a flag, I'm sure. Except for there's this one little problem, which is that it turns out that companies like Google and Apple are actually very good about keeping their devices up to date. And when a new version of Unicode is released, this timeline is 100% realistic. That it's typically less than a year from when a new version of Unicode comes out, which has brand new characters that have never before been used. These days, the bulk of the new characters are emojis, but there are absolutely like letters. One thing that I came across was somebody who was working with a language from rural Pakistan that was often written with an Urdu script, but it could also be written in an Arabic script, and they had to add some of the missing Arabic letters. And that was very recent. And this sort of thing is kind of always happening. And it's less than a year. How many of you always have your Postgres databases updated every single year to the latest version, right? No. So if your database is going to reject unrecognized characters, then it's going to throw an error for anybody using the latest iPhone. So there's kind of a dilemma there, right? Fortunately, though, we can be confident. Postgres will throw out a warning message, and at least I know somebody will see this message, surely. Except if you go back to that blog post from a year ago, you can walk through this step by step yourself. And this is a picture of dbeaver, and this is the picture from the blog post. Cut and paste. You can do it yourself if you don't believe me. It will run that query. All of the data will completely vanish. There is no data. It's gone. 0 rows returned. Mind you, this is right after I inserted the rows. And at no point is any warning message ever displayed to a user. Now, under the covers, what kind of happened here is that Postgres did kind of send a warning message at connection time, not query time, back to the client. And the client probably has it like somewhere in a log that was not actively displayed to the user. But at least, fortunately, we know that administrators are going to read their logs, right? And I'm sure you immediately saw the problem here. You see it? Everybody? No? It's right there. Well, the reason you didn't see it right away is also the reason that most likely administrators are not going to see this lovely little warning message until after they've had a corruption or data loss or other major problem and they go looking for it. Fortunately, though, we can reliably emit these warnings because we always know what version of C libraries we're using, right? Again, well, on the common operating systems, we're good. All right, so we've got like Linux, most Linuxes, FreeBSD and Windows. There was a patch for Mac. It hasn't quite, but even that patch I think was just kind of grabbing the major version of macOS because we couldn't quite figure out where to get it from. We don't have that new C library. There's a whole bunch of platforms where we're not even quite able to get the version of the C libraries we're using. Now this is a fun one, number 11 that I got wrong. Somebody threw out this idea. This is absolutely crazy. They said, well, what if we just extracted all the collation code from an old version of glibc, build it as its own little library, and install that in the new major OS? And this one, I will tell you now, I absolutely, the moment I saw it, I was like, no, you cannot do that. Not gonna work. So I put his picture up here. Now, I will still maintain there are like 5 people in the world who could have pulled this off. And I will also say, I'm not saying this is like the ideal solution, because it's not. Like, this isn't like an ideal long-term solution. But Joe talked about this last year at PGCon, and it is pretty impressive. It turns out you can actually do something like this. Number 12, and this is the one that all of us so badly wanted to believe 5 years ago, which is that ICU is going to solve everything. Oh man, I wanted to believe this so much, so much. Now, don't get me wrong, ICU is a far better choice than your operating system C libraries, all right? Unfortunately, it doesn't quite solve everything. In fact, going back to the collation torture test, we took it and we pointed it at ICU2 and looked at the last 8 years. And once again, every single release of Ubuntu in the last 8 years, even in ICU, is seeing sort order changes. So it's the same type of thing. There are still changes happening all the time for many of the same reasons. But fortunately, at least ICU never had a huge sort order change like the 228 fiasco, right? It's at the top. Sorry to break it to you. So quickly summarizing the torture test stuff, both glibc and ICU have had regular collation changes. They've both had one with a huge number, and you can go to GitHub. You could also do a checksum and build your own test. There's some nice stuff there. Number 14, so ICU is changing all the time, but I'm sure we can just assume Devram and Christoph would be happy to build all the old ICU versions for you, right? Are they here? Well, all right, unclear if we want this. Please hop on the mailing list. It'd be a fun discussion, and obviously I'll put in there new contributors are always welcome. Number 15, sort order surely would not change. At least we could know in a library update that was just patch version changes, except for when it did. But at least it wouldn't change if there's no version changes, right? Like, at least if the version is the same, the sort order would be the same. You would think that at least you could assume if the version number didn't, unfortunately, this turns out to be sad too. I'm almost crying. Yeah. And sadly, Postgres does not yet have any kind of a built-in collation that avoids all corruption risks. Now, this is a fun one because I knew this, and then I kind of forgot it for a while, because it turns out Postgres all along has had something built right in that avoids all of these problems, and that is something called the Posix locale, or also called the C locale, and this is part of the Posix standard. So this has actually been there, and what this is that this is sort of like when you normally think about putting words in order, you're thinking about doing it the way humans do. This is kind of like a computer-oriented version of that, where what this does is it sorts strings or Unicode strings or words by code point, which is kind of like, just like a binary sort of the word. So it's not intended to put things in like a natural language order, but code point order is a well-defined thing that's not going to just change on you, right? So there's that. Now there is one kind of other interesting little thing that I somehow missed at first, which is that Postgres has a C, and then it has a C.UTF-8. And I kind of assumed originally that these were the same thing. It turns out they're not. These are actually two different things. And I'm talking about the libc provider built in, this has been in Postgres forever. And there's two different ways you can set the collation. So the C collation, it's a little bit misleading. It's not actually coming from libc at all. It's not calling out to glibc. That is entirely implemented internally in Postgres. It is stable, it is safe, it won't change, and it's been there all along. The C.UTF-8 collation is also doing like a C-style locale, ordering by code point, but that's actually relying on your operating system C libraries. Fortunately, though, it's code point ordering, so that wouldn't change, right? One would hope. I have no idea how glibc managed to get this wrong. I really don't. But it turns out glibc, and there's this whole thing from this is when they started the project to fix it, was in 2015, to fix glibc code point ordering. Like, how do you even get that wrong? So it turns out every single distribution has had some kind of a hacky workaround for years, none of which were perfect. And then glibc fixed it, and basically Daniel had this great classic email to the list where he's like, oh, by the way, code point ordering changed 4 times across 4 different versions of Debian. So that's sad. So we have to amend our table to say that the C collation is stable and safe and doesn't change. Unfortunately, the C point, now this is still going to be better than linguistic sorting. It should be far less likely to have issues, because that was kind of some bugs and some issues. It's a more well-defined order. That's not going to be changing. But unfortunately, the history is not good, right? Number 20 is that the collation is only for sort order. Now, sort order has been what's getting all the attention, so you'd be forgiven for thinking this, but it's not just for sort order. And this also brings us around to the problem with the C locale. So the C locale is stable, and it is safe, and it doesn't change. But the problem is that the collation provider in Postgres also has a second very important job, which is character semantics. And that's things like if I throw a character at you, what is it? Is it a letter, a number, a punctuation, a white space? Is it uppercase? Is it lowercase? Just that little set of rules, which varies by language. Especially, so let's see, the uppercase and lowercase. No, yeah, the uppercase and lowercase can vary. You've got a couple kind of interesting rules in German that are specific to German, and a couple other things. So the C locale, unfortunately, only understands ASCII, and this was an example which you can run in Postgres and see. And you can see how, if you take that lowercase, it looks like a name, but if you look at what it's done, how it's tried to do the init cap function on it, The accented character, because it's not ASCII, it doesn't understand it. It doesn't think it's a letter, which is why it capitalized the second one. It can't uppercase it correctly. So the C locale is stable and safe, but there's kind of some usability issues because you have a whole bunch of like regular expression stuff, capitalization stuff that isn't going to work right. If you're only dealing with ASCII, that'd be fine. But unfortunately, this is a C locale while your database is running in Unicode mode and accepts every single code point of Unicode. But luckily, the C type at least wouldn't change, even though the UTF-8 screwed up well, unfortunately, that's not true either. We're also concerned about that changing. But now here I'm going to bring it around to the real rub. The real rub with all of this, like code point, is like even if it was stable and safe, surely users would never stand for it, right? Because one of our core problems here is that like, the people using the systems are not robots, they're people, and they need to see words in an order that makes sense to them. Whereas all of this code point ordering, it's like binary sorting, is going to like put letters and words in an order that's kind of nonsensical. And surely no widely used major database today would default to something like code point ordering, right? Well, this is what I thought until a couple weeks ago when I started actually doing the work and digging in and figuring it out. And what I discovered was, in fact, a whole bunch of major widely used databases do exactly this. They default to code point ordering. And I was very surprised to find this out. Now, it's interesting, there's some kind of, the other thing I discovered was that every single major database has at least one really weird quirk around collation. It is bizarre. Like everybody has something. DB2, there is a way that you can tell it to run the database in a linguistic mode, but even if you do that, like those catalogs are staying in binary mode no matter what. Another fun thing about DB2 is that they have like some weird stuff to support like really old code pages from the 8-bit encodings before we had Unicode, where like it'll actually behave very much like the C locale. It'll sort only your 8-bit letters correctly, and then all the Unicode stuff gets code point ordering. Oracle is the best. They're super bizarre, which is that it all depends where you live. If you're in the States, everything, if you speak English in Oracle, everything is just code point ordering, and it tends to work. But let's hope you don't live in Europe or Quebec or the Middle East or a handful of other random, completely random countries. It's like if you speak Urdu, you're out of luck, but if you speak Hindi, you're fine, I think. Like there's this list in the appendix of the Oracle manual with a list of languages. And what happens if you're one of those languages is the order by will do the language. The greater than and less than operator would do code point. Yes, it's wild. So like I've got an example on the blog of like it's like select star from table, order by name, and then select star where name is less than J, and like it's just like the middle three show up. It's crazy. And the even crazier thing is I talked to some people this week, because I've always run it with like English. I talked to a couple people from Europe, and they're like, yeah, that's how it's supposed to work. We just kind of accepted it and got used to it. I was like, really? No way. So anyway, this has been interesting because there's an ongoing discussion in the community right now. And one of the things that I think that this is kind of lends some support to is the idea that maybe it's actually not so unreasonable when you're running Postgres to set your database default to binary to code point ordering, and then to do your linguistic sorting either at a query level or maybe at a table level or something like that. And finally, I need to head over to Jeff in a minute here. Number 23, the last thing that I got totally wrong, which is that I know Postgres, and it takes forever, right, to get anything like finally shipped in Postgres. And surely there's no way that like, especially on some kind of a short timeline, we would get a built-in collation that solves all these problems. No, impossible. Now I will hand it over to Jeff.
Thanks, Jeremy. Yeah, I've been under most of those misconceptions myself at one time or another. Let's take a step back for a second. So now we're going to kind of, it doesn't have to be so bad. Let's build up from the beginning and, show how we solve some problems. And as, along the way of improving our natural, language support, we're also introducing some new problems. It's a bit of a trade-off, but you'll be able to see where those fit in a little bit better here. So, first of all, after hearing that list of things, you'd certainly be forgiven for thinking like, forget it, just make everything, binary sort and let me, handle the rest in my application. So how many people here are thinking that right now? Okay, so I see a few hands there. Certainly that's a reasonable starting place. But let's just, talk through how we can, what that would mean to start off with something like that, what problems we'd have, and then see if we can solve those problems without creating too many new problems. So first, at the base level, this, locale C, it's the non-locale, right? It's binary sort order, and all the character semantics, uppercase, lowercase, accents, all this, it only understands ASCII. It's very limited, so you run into exactly the kind of problems that Jeremy brought up earlier with accented characters that are case mapped improperly. So you have this really basic starting place, and you start off, that has a few problems, right? The first problem with the locale C is it can be on any encoding, and the binary sort, if you're on UTF-8, that's going to be code point order. But if you're on some other encoding, it might be a different order. So you could actually have two databases, and both of them, you're using locale C for the sort order. And if they're on different encodings, you can get different results. So that's not ideal, right? It should be the same moving one system to another. You shouldn't be able to produce two different sort orders in that fashion. The second problem is that, as Jeremy pointed out earlier, it doesn't handle the uppercasing and lowercasing properly. Accented characters are one example of this, but of course there are many others, right? Greek letters have uppercase and lowercase variants, and there's no reason that shouldn't be able to be handled properly. The third problem is that capital Z sorts before lowercase a when you're doing code point order. And as programmers, computer scientists, we're used to this by now for exactly what Jeremy and I guess Peter said earlier, is that computers have influenced our conception of what how strings should be ordered. And if we are used to the ASCII ordering, which many hastily written applications do, then we've actually kind of gotten used to that. It's maybe not good because in reality, you do want all the A's before all the Z's. I believe in every language that uses those. And so that's not ideal. And the last problem is, no case-insensitive sorting or anything interesting, right? You're just stuck with this very basic semantics. So let's take this up one level. And this is something that's been improved a lot in version 17. So Jeremy mentioned quite a few caveats to trying to use the c.utf8 locale, but in spirit, that locale is actually kind of a nice compromise for some use cases. If you're okay with the code point ordering, but you just want the accented characters and other character semantics, pattern matching, that kind of thing, to work properly in a wide variety of languages, then this is actually kind of a nice balance for some workloads. It's got the simplistic sort order. We're still going to have some problems with that, but at least we have better character semantics. And those character semantics are much, much more stable. You're much less likely to have a problem due to some kind of a Unicode change based on, for character semantics than for sort orders. Sort orders change in kind of subtle ways with white space and all kinds of interesting ways that those might be ordered differently from one version to the next. Uppercasing and lowercasing is much more static in Unicode, and there are even some compatibility guarantees around that. So you're much less likely to run into problems. So you can get better language semantics, at least for the characters, without without compromising some of the simplicity of the code point order. Now, of course, this still has problems. The capital Z still comes before the lowercase a, so this is not a great way to display data to humans. And you still have this simplicity, which is good and bad. The bad part is you can't do case-insensitive sort orders, that kind of thing. And then, of course, if you're not on 17 yet, you'd be using this only through the libc provider, and that has the caveats that Jeremy mentioned before. So in version 17, we've essentially solved the caveats with this provider, this c.utf8 in spirit, and that means that it's going to be entirely stable within a version. It's going to be consistent from one Postgres instance to the next, regardless of the platform, and it's going to provide good good performance and consistent, good semantics for characters.
Jeff, is it just solve the last of the three or all three?
Just the last, sorry, I didn't indent very well there, but then the libc thing, don't, if you're able to use libc, then, you want, sorry, if you're able to use version 17, don't use libc because you're going to just expose yourself to those problems. So instead use version 17 with the built-in provider, and that actually solves any of the libc related problems, which aren't inherent to the idea of a c.utf8 locale. So then you take kind of one step up from that. So one thing that can make sense in a lot of cases is the ICU root collation. This is a natural language sort using ICU. It's got really nice sort semantics. It's not especially designed for any one language. It actually it's essentially American English or something. I think it's identical to the ENUS sort order, but it does provide. It's meant to be somewhat not tied to a specific locale. That could be a reasonable thing to do if you want natural language sort order within your database, but you don't want to, and you want it to be consistent across your database, but you don't want to tie it to any one particular locale. This, again, like I said, it's essentially the ENUS locale for ICU, and this solves the Z is less, capital Z is less than lowercase a problem. It's going to sort those things correctly. It's going to handle white space and other more complicated patterns of text. So it is a natural language sort. It's ENUS-centric collation, but if you want natural language and you don't necessarily know which locale you'd like to tie it to yet, then that could be a way to start. This solves some of the natural language collation. It solves the natural language issues with the other C and C.UTF-8, but it still introduces now a couple more problems. The sort order can change from different versions of ICU. So you've introduced a lot of the problems that Jeremy was talking about earlier. When the version of ICU changes, now you're going to expose yourself to index inconsistency risks. And in addition, it's going to be slower performance simply because it's a more sophisticated way to order strings. So that has a performance cost. It's substantial, so it's something to keep in mind. Maybe not an overriding concern, but it is substantial. So we can kind of move on here for a quick example of how you'd actually use these things. To use initdb, it's a little bit different from what you do to within a SQL query, so I'm going to put both up here. So to initialize a database with the locale being c.utf8 with the built-in provider, that's the way you initdb. That works on 17 and later. The beta is out now, so feel free to try that out. And then if you want ICU, here we're using the root locale, which is spelled as the undefined language, meaning not specific to a locale. And that's available from 15 on. So you can make that the default collation for the database. That'll affect every query you issue without a collate clause. It'll affect every index you build without a collate clause. It affects all kinds of operations. So that just be aware that it affects everything.
If you don't specify a locale, what's the default for these two providers?
They do not have defaults. So if you specify, the only one that has a default is the libc provider, which defaults from the environment. Now, defaulting from the environment with libc is a little bit suspect as well, right? Because the machine you run initdb on does not necessarily reflect the wide variety of users, customers, employees that might want to use or have data in your modern database. As Jeremy pointed out, even in Vancouver, I'm sure that there are people representing almost every script and language and region from one place or another. So that is pulling from the environment. In some senses, it doesn't always make sense to have a default that is locale specific. And that's one of the advantages of, say, c.utf8, is until you know what locale you actually want to use for a particular query or column or whatever it may be, then it might not make sense to just kind of choose English, say. And in here, if you want to get a little bit more precise, this is really useful. So you can, this is just demonstrating the collate clause. And so this can be tied to a column or used right in a query like I'm showing here. And so by using the collate clause, this allows you to, when you actually know something more about the locale that a particular column or a particular query wants to use, then you're able to tie the collate clause to the locale you'd like to use. So in the case of the built-in provider, we could use the collation PGCUTF8, and that would be the c.utf8 locale. And in the case of ICU, we can use collate Unicode gives us the root collation. We can also have more specific collations in a second that could be locale specific. I'll show that as well. So here we'll just go through a couple of ICU more advanced usage that, again, once you know more about your system that you might make use of. So here, this is a case-insensitive collation. So in this case, we're using ICU for deterministic. That's an important keyword here. And we're turning that off. And what that means is that two strings could be equal even if they're not binary exactly the same in binary representation. And of course, for case insensitive, that's a requirement. If we, two strings with different case variants will end up being equal. So here, that's just a simple example. Here, once we know maybe that we want to use a specific locale, the French, the Canadian locale, we can, here in, again, ICU, specify that locale. And see here, we've defined the name as French_CA, and we're using that as a part of the collate clause. And that could be, again, tied to a column of a table or to a specific query that we're running. And then this one's interesting. I never thought that this would work as well as it did, but for numbers inside of strings, you can actually make the sort understand that it's a number and understand that one number is less than another number, not just purely lexicographic comparison of the digits. So if you look here, 45 is less than 123. And so conceptually, that makes sense, right? So you compare 45 is less than 123, so ID 45 is less than ID 123. But this looks a little bit strange to somebody who's a programmer because we expect lexicographic comparison. So what we actually have here is the fourth character in the first string is a 4, and the fourth character in the second string is a 1, so we're used to that actually returning false. But ICU is sophisticated enough to understand that that's actually a number. In the case we use this specific locale options, we've done some ICU customizations here. I don't have a pointer here, but if you look at the locale definition, then that's an option essentially we're turning on to recognize the numbers and treat them as numbers rather than a sequence of digits. And that way you don't have to zero pad numbers, for instance. Some ID numbers might not be zero padded.
Does that work if the prefixes are not the same?
If the prefixes are not the same, then those would be higher precedence in the comparison. So if we did the same thing with a, ID, one of them's ID and the other's IE, then we'd see a potentially different result. But here, it's the same preceding that. I thought that it would make more sense if I made it a part of a string that included non-digit characters, because otherwise it looks almost like it would be casting them, right? But here, they're not being actually cast by Postgres to a number, but ICU still can understand that.
Is there any cheat sheet for those special ICU?
Yes.
Yeah, there is in the docs. I went to quite a bit of effort to make some tables and so forth in the docs. I could, if you go to the localization chapter in the docs and look for ICU customization or custom collations, I think, then there are tables of, what these options are, how to put them together. You can combine, for instance, the ability to recognize numbers with a case-insensitive search and a number of other interesting things that you might want to do.
And Peter's blog is actually like an amazing reference that goes through, like explains everything, like exactly what that string means, like the letter KN tells you what all the other things that you can put in. It was very good, very, very good.
So as far as future work, we'd like a more compliant UCS basic. We'd like to implement Unicode case folding, which is a feature. It's kind of like just lower casing, but it's meant to be more static from release to release, and you're able to avoid versioning problems with case folding that you might have with the lower function. We need to establish a little bit better guidelines for when to use code point order collations versus when to use natural language collations. I think that is an important decision, and that users need kind of a guide to understand what they're, just much like this talk, what problems they're solving in one and what new problems they're creating. And then they can choose based on their use case. Then also, should we reject unassigned code points? Unassigned code points would be if your Postgres version may be older, and then as Jeremy said, the iPhone may be new, and then if that's entering into a form, that may make its way into a Postgres database that's older, and it might not know about that character yet. That can cause problems with less stability in sort when you want to upgrade ICU later. It can cause also some problems with, if they're introducing new case variants or something like that may affect the results of upper or lower. Should we offer an option to enforce Unicode normalization? This could be kind of an interesting thing. For the most part, when you're comparing values, you want to treat a lowercase a code point followed by an acute mark the same as the combination single code point that represents the a with an acute. So that's just different representations in Unicode of essentially the same thing. The other question is, should Postgres take responsibility for managing different versions of collation libraries? We've got all these problems that Jeremy brought up. A lot of those are related to managing the versions of the libraries that we're using as dependencies for collated sorts. If we did a better job of managing those libraries, would that be helpful, or would that be too confusing? Is there a simple enough way to accomplish that? And then, in conclusion, code point order collation is fast and stable and simple. Natural language collations produce superior results for humans. not every single database is consumed by a human. So some are consumed by other complicated applications, ORMs, fed into other database systems. It could be a foreign data wrapper to something else. It could be part of a larger data architecture that goes many steps before it actually reaches a human. But if it is going straight to a human, or nearly so, natural language collations will produce a better result and can produce more consistent results if you have multiple applications accessing the same database. The C.UTF-8 locale is a code point order. It's not a natural language, but it provides somewhat of a balance by at least getting the character semantics right and being consistent within a Postgres version, regardless of what operating system upgrades you might do. Especially the improved version of this locale with the built-in provider offered in version 17, which is not released, but it's in beta. So again, please try that out. And then, so you choose what makes sense, and then you use the collate clause if you need to make changes to particular columns or particular queries to make a different choice. So, thank you. Question?
I think you did some performance testing. I think you kind of undersold the difference in performance of some of
Yeah, that is true. The performance, especially compared to libc, the code point order sorting is dramatically faster than libc, to the point where overall queries can be affected, from easily, 5x or something, and that's so natural language collation, you really want to be aware of that cost. And that can be a good reason to be, to use the database default as a C.UTF-8 with a built-in provider, and then kind of be more selective about which columns and queries use other collations.
Is that true even if you're using libc's code point ordering? Is that still slower than the others?
So the C collation is actually not using libc at all. So that one is fast. But the C.UTF-8, if you're using libc for that, then it is slow. Yeah.
And that's just the comparisons for the btree traversal, though, that much faster?
It doesn't.
Lookups or...
I mean, it could be, so following an index could be a part of the slowness. Sorting values, for instance, for a group by, building an index, kind of all of the above. So it can be very substantially slower. And so that libc's, if you're going to libc, which in the case of, earlier, versions, if you do C.UTF-8, that can only use libc. Even that one, even though it's code point order, modulo a few caveats that Jeremy brought up, then that is dramatically slower.
Now that's still a little faster than doing linguistic sorting with libc, right?
Yeah.
So it is a little bit quicker than C.UTF-8. It ends up being faster than C.English or C.French, but it's slower than the built-in or the ICU stuff. At least that's from the numbers that Jeff has run so far.
Yeah. Now, if you're using natural language collation order only for the top level, then typically, if you're returning something to a human, you often aren't returning, millions of rows to a human, because millions of rows, would take a long time to read. Sorry, question?
So since Postgres 16, ICU is used as the default in the builds. Is there a discussion where the default would be to force a different built-in provider like the C.UTF-8 such as you would get actually faster queries by default?
Yeah, I mean, I think that's an ongoing discussion. I think getting from the environment doesn't make a whole lot of sense. So what we're doing now, I feel like, is the worst default, because we're by default choosing libc, which is the worst provider. And then on top of that, we're using a natural language collation that is not, that is incredibly slow and not necessarily representative of how you're going to use your database.
And I didn't
So,
catch. Mikhail, did you say you were thinking ICU was the default in 16? Changing it to be built-in stable.
yeah.
Because I think today the default is still libc. We tried, like it flipped to ICU for a while and then it was reverted.
Yeah, I think that is a discussion we should have. I don't think coming from the environment is the right choice. I don't think libc is the right choice. So I would like to make some kind of change here. It would end up, I think we should absolutely have that discussion. The default should not, we should not choose too early a natural language collation without the user really understanding the consequences of that and without even really having a clear idea what locale they actually want their database to be in. So yeah, we need to have that discussion. We tried to make a change in 16, that didn't quite work out. So we're gonna let the built-in provider settle a bit and then see if it makes sense.
One other thing, I think there's sort of another advantage. If you set your database default to code point, but you still use linguistic collation, like say at a table level, because you can, in your DDL statement, you can, right next to a column definition, put a collation there, right? One of the advantages of that is that when it comes time, say you want to update your ICU libraries, at that point, it's far easier to figure out all the places that collation is being used in your database because you have dependency tracking inside of Postgres. You can look and see, whereas when you just set the database default to a linguistic collation, it's kind of like, well, anything and everything could be using it, right? So by setting the database to code point, but then using it at, even at a table level, it's very easy. It's very easy to look at your catalog and see like where you're using, and then you can very kind of quickly figure out, you just rebuild a few indexes. You could say definitively, I have no range partitioning concerns whatsoever, because I know I don't have any range partitioning that uses linguistic collation. Yeah, anything else? I think we're good. Thank you everybody for coming.